Okay, so we will solve today's problem. This is about propositional logic and giving inference using propositional logic. So let me read this problem. Given the following statements. First statement, if the package has been shipped, it will arrive. The second is, if this package is expected to arrive today, it will be delivered today. Third statement is, the package has been shipped. And the fourth, the package is expected to arrive today. So these are the given statements. So the given statements actually they compose our knowledge base. So this is our knowledge base. So what we will prove is that the package will arrive and it will be delivered today. So two methods we are going to use in order to arrive at this sentence or to prove that this sentence is true. One method is using entailment by the use of truth table, and another method is using the rules of inference. Okay, so we will solve them one by one. So we'll have our answers here. Okay, so before we can use the truth table or the rules of inference, we have first to represent our statements using propositions. Okay, so for this one, so that's the knowledge if the package has been shipped, let us represent that with a proposition. So for example, we will represent it as proposition S. Okay, so let us say S, it means that the package has been shipped. Okay, so therefore, if we represent the knowledge the package has been shipped, we will just use S. And then another knowledge will be that it will arrive. Okay, so the package will arrive. So let's represent it with a proposition, let's say A, or any proposition, as long as it's a valid proposition. So A, it means the package will arrive. Okay, so that's our second proposition. Another here, so we will, from the given statements, we make sure that each knowledge there is represented as a proposition. So another will be the package will arrive today. Okay, so that's just the same as this one. It will be using the proposition A. Another knowledge will be delivered. So the package will be delivered today. Okay, so we haven't represented that knowledge yet. So let's say delivered. We will represent it with the proposition D. So the proposition D means the package will be delivered. Will be delivered today, or will be delivered. And then, okay, this one, the package has been shipped. So already we represented it with S. The package is expected to arrive today, and it's represented already with the A. Okay, so all the knowledge here in our given statements has been represented already through propositions. These are just the propositions. Now, our knowledge base is composed of these four statements. Therefore, we have to represent it. We will convert our knowledge base using propositions, using these propositions and the connectives. Okay, so let's represent it. So these are the propositions. Let me just okay, so these are our propositions. So let us label it propositions. Now let's convert the knowledge base based on the propositions. So our knowledge base now. So the first one, if, so this is a rule, if then. If the package has been shipped, then it will arrive. So if package has been shipped, this is proposition S. Okay, package has been shipped. So that is proposition S. Then if this is true, then the package will arrive. Package will arrive will be proposition A. So we will form it like this. So if S, then A. This is our first statement in the knowledge base. Now the second sentence or the second statement, if package is expected to arrive today, then it will be delivered today. So expected to arrive, we will use proposition A, and then delivered we will use proposition D. So it will be A. If A, then D. That's our second statement of the knowledge base. And then the third will be the package has been shipped. So that is just simply S. And the fourth statement in the knowledge base is the package is expected to arrive today. And that is A. Okay, so these are our sentences in the knowledge base. So now we will be forming our truth table. So for our truth table, since we only have 3 propositions or 3 variables, therefore our truth table will have 8 rows. 2 to the power of 3. So we have 8 rows or 8 interpretations. So all the propositions are here, S, A, and D. So we will just add to our truth table the knowledge base statements, the sentences in our knowledge base that are not exactly the same propositions as here. So the first one is S implies A. We will add it to our truth table. So S implies A. The other one is A implies D. Okay, so the third and fourth statements in our knowledge base are S and A. They are already the propositions in our truth table, so we don't need to add them. It's exactly the same of this one. So let us have the truth values for these two columns. S implies A, that means it is an implication. If S, then A. In the implication rule or in the implication connective, we know that there's only one case that the implication will return false, and that is if the premise is true and the conclusion is false. So if it is in the form if true then false, then the implication will give false. Okay, so if true, so our S is the premise, so let's look for the premise is 1 and the conclusion is 0. So this part here, it will give us false value for this column. So this will be false and false. The rest are true. So this is true, 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 true. Okay. Now same with A implies D. So A is the premise and D is the conclusion. So we will check when A is true and D is false. So that's the case that it will return false. Also from here we have this. So this is false. The rest are zeros. 1, 1. Okay, so these are all, the rest are true rather. Okay, so true. So these are now the first two sentences in our knowledge base. And then the third sentence is just S and the fourth sentence is just A. Now we will have the truth value for the knowledge base. What is the knowledge base? The knowledge base is just the conjunction of all the statements. So this column here, so these values, and S and A values also, we will combine them using AND. That will now form our knowledge base. So we know that, so it will be S and A, and S implies A and A implies D. All of these. We know that the conjunction will return true if all the values are true. Therefore, here this will be 0, 0, 0, 0, 0, 0, 0, and 1. So this is our knowledge base. Now, this is not yet the entailment. We want to know if the knowledge base will entail A and D, because we want to prove that the package will arrive, that is A, and it will be delivered today, that is D. So A and D. A and D. Let me add a symbol here. Okay, so we'll get first what is the value for A and D, and then we'll add the entailment KB implies A and D. So the A and D is these two. Okay, let me remove first the highlight. So A and D, so we'll get the value. So this will be 0, 0, 0, 1, 0, 0, 0, 1. And the last column will be, we want to know if the knowledge base will entail A and D, will imply A and B, A and D. So KB implies implication A and D. So the premise is the KB and the implication is A and D. So since KB here is all zeros, so it will be returning true. And since this is if true, then true, then all will be true. So all here will be true. Therefore, it is true that the knowledge base entails A and D, since all of these are 1. Okay, so that is our proof that it is entailing that the package will arrive and it will be delivered today. Okay, now we will prove that the package will arrive and it will be delivered today using another method, which is the rules of inference. Okay, so we'll start. So using the same problem, so we already represented our knowledge base with the statements here. These are our statements in the knowledge base. So when we use the rules of inference to prove something, we have to provide reasons for every statement that we will create. So we will look first through reverse engineering. What we want to arrive at, or what we want to prove, is that the package will arrive. That's A. And the package will be delivered today. So what we want to do is to prove A and D. Because this is A and this is D. All right, so from the given knowledge base, is there anything here that says A? Yes, there is, because it's included already. There is a statement A, it's given. But what about D? D is not given, but there is an implication that concludes D. We can use this. But in order to prove D, we must have proved A. A is given already. Okay? So therefore, we can start with this. A is given, and this one is given already to be true. So we have here the first statement that we can form in our proof is, first we have the A. And what is the reason? That is a premise. Premise means it is given already in the knowledge base. Okay, and then we have an implication, or we have a sentence, A implies D, from our knowledge base. A implies D. Okay, the reason is Also, it is a premise already. So if we will combine these two, applying modus ponens, it will give us D. So what did we use? We used the inference rule modus ponens on statements 1 and 2. Our step 1 and 2. This is our step number 1. This is step number 2. So we apply modus ponens to those. So we have now D. Okay, so this is the derived sentence or the inferred sentence. Next is we already have A as a premise and we have proven D using modus ponens. Now we can put them together. So we will be having A and D, A and okay. So what we did is just we introduced the and connective. So and introduction to our statements 1 and 3. So actually this is already what we want to prove. So we have inferred that the package will arrive and it will be delivered today. So only 4 steps required. Okay, so that's it.